All right, guys, today we're going to be working on rectangles, rhombuses, and squares again, but today we're specifically doing the conditions, which are kind of the same as the properties, but we will be proving something is a rectangle, rhombus, or square. And that's going to be on pages 80 and 81. So go ahead and label that, turn to 80 and 81. 79, here is 80. .4 conditions for rectangles, rhombuses, and squares. And just like the conditions for parallelograms, they're very much going to be the same. It's just now, instead of saying these things are true because we know it's a rectangle, we're going to say we know it's a rectangle because these things happened. Okay, so it's going to be the opposite we're going to be proving today. And that's the title for 80 and 81, so I'm going to go ahead and label both. All right, and we are writing quite a bit again. We're going to start with rectangles. Okay. Now, first of all, though, we're going to write a whole list, but a little side note here. Before any of the following conditions will work, so before we can use them to prove it's whatever figure, you must know it is a parallelogram. If it is not a parallelogram, it does not work. So for all of these, everything we do today, we have to show it is a parallelogram first, every time. Okay. All right, so we're just going to write down the conditions. So conditions for a rectangle. First one, if one angle of a parallelogram is right, is a right angle. Let's get the proper wording there. Then it is a rectangle. And we're going to write, then it's a rectangle one time instead of over and over again. Okay. So notice it's a parallelogram first. If it's a parallelogram and it has one right angle, then it's a rectangle. Also, if the diagonals of a parallelogram are congruent, then it's a rectangle. So here's the then statement. Then the parallelogram is a rectangle. You will use either one or two to prove that something is a rectangle. It has to be proven that it is a parallelogram first. These are the conditions, and you'll just write down that's a condition for a rectangle in your proof. They are technically theorems, but they are not named theorem. It's just theorem. They stop naming them after a while because there are so many theorems. If it's not a special thing, they don't name it. It's just one of the rectangle theorems. All right, conditions for rhombuses. There are three. The first one, if one pair of consecutive sides, let's talk about what that means. Consecutive sides are next to each other. That's not part of the proof or the actual condition. I just need you to know what consecutive sides means. Of a parallelogram are congruent, then it's a rhombus. The second one, remember only one has to be true. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. And 3, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. By the way, all of these so far say specifically if one pair of sides are congruent. If you know that both or all four sides are congruent, then you don't actually have to know it's a parallelogram, because you could just say definition of a rhombus. So these conditions are using parallelogram because it doesn't have all the pieces. Okay. Last, let's talk about the conditions for a square. Conditions for squares. Proving that something is a square takes longer. However, listing the conditions is less work. So if one condition for a rectangle and one condition for a rhombus is true of a parallelogram, then the parallelogram is a square. So you just have to have one of each. Okay, one of each. All right, we're going to do some examples now. We're going to be more proving than we did yesterday. You need to tear out page 462 and 464. I'll write that down. So let's tear out 462 and 464. Okay. From 462, you need to glue in this That's all you need from 462. From 464, skip about 3 lines and then glue in example 3. And that's all you need to cut out, and we're going to do these examples. Skip 3 lines and glue in example 3. We'll leave the room at the bottom to write, so there you go. Let's get started on these examples. Okay. 4 and 5 are using the same diagram, just like in the past. 4 does not have anything to do with 5. We will start all over again with number 4, okay? Actually, it says use the given information to determine whether the quadrilateral is necessarily a rectangle. Explain your reasoning. All right, so here's what we know. We know that EF is congruent to GF. Okay. We know that FG is congruent to HE. We know that FH is congruent to GE. I feel like there's a typo there. There is, sorry. The book made a mistake. This should say GH. So let's erase this. Start over. The book made I knew there was a typo somewhere. That's there, GH. In your homework, if you think there's a typo, ask. It doesn't necessarily mean it because it says if it's necessarily a rectangle, the answer could have been no. Anyway, so EF is congruent to GH. FG is congruent to HE. And it says FH, this whole thing though, is congruent to GE, the whole thing. All right, let's think. Rectangle. My conditions are if one angle of a parallelogram is a right angle. I don't have that one. The other one is if the diagonals of a parallelogram are congruent. Are the diagonals congruent? Yes, right here, the diagonals are congruent. However, are the diagonals of a parallelogram congruent? First, is it a parallelogram? Well, with 2 sets, EFGA, these two and these two, of opposite sides, congruent, I know that EFGH is a parallelogram. Okay, so I've got the first part. It is definitely a parallelogram. Okay? Now that we know it's a parallelogram, do we have one of the conditions to prove it's a rectangle? We have that second one. The diagonals of a parallelogram are congruent. Since the diagonals of E, F, G, H are congruent, it is a rectangle. So we are good. We have that it's a parallelogram, which helps us show it is in fact a rectangle. My ink ran out because I got some glue on that paper. All right, pause the video and try number 5 on your own. Okay, now that you've tried it, number 5. Remember, this stuff is not true anymore. And if you didn't realize that, then pause the video again and try it again. This stuff is not true. We gotta talk about what we know, and I hate it every time I erase, my camera shakes. Okay. Given that FEG is 45 degrees and that GEH is 50 degrees, is it a rectangle? Well, I don't even care if it's a parallelogram or not. That's 95 degrees. No. EFGH is not a rectangle, since the measure of angle FEH is 95 degrees. So that one is no. That can't happen no matter what. You can't have a 95 degree angle. If it was 90, that's all well and good, but we can't even prove it's a parallelogram. Not with that information. There's not enough. All right, example 3. Determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. Here's what we know. We know that AB is congruent to CD. We know that BC is congruent to DA. We know that AD is perpendicular to DC. That means there's a right angle right here. And we know that AC is perpendicular to BD. So we got some opposite sides congruent. We have one right angle. We have diagonals that are perpendicular. Is it a square? Okay, let's look at the conditions for a square. We have to have one condition for a rectangle, one condition for a rhombus, and it has to be true of a parallelogram. So we need to prove it's a parallelogram, then we need to prove it's a rectangle, then we need to prove that it's a rhombus, and then finally we can say it is a square. That's why squares take a longer time. So let's get started. First of all, is it a parallelogram? Well, the opposite sides are congruent. So since the opposite sides of A, B, C, D are congruent, and it should say since both sets of opposite sides. Both pairs of, there we go, sorry. Let me move this because this is hanging off and it's driving me nuts. Are congruent. A, B, C, D is a parallelogram. There's the first part. Now, is it a rectangle? Let's look at the conditions for rectangles. All right, if one angle of a parallelogram is a right angle, that's the first condition. Do we have that? Yes, we do, right here. Since angle D is a right angle, is it angle D? Yeah. A, B, C, D is a rectangle. Of course, if you were actually doing a formal proof, the reason would be condition of a rectangle. Okay, it's a parallelogram, it's a rectangle, is it a rhombus? Let's see. Number 1, if one pair of consecutive sides of a parallelogram are congruent, we don't have consecutive sides congruent. Number 2, if the diagonals of a parallelogram are perpendicular, the diagonals are perpendicular. There's our rhombus. Since the diagonals are perpendicular, A, B, C, D is a rhombus. Okay, it is a parallelogram. It is a rectangle. It is a rhombus. So, therefore, ABCD is a square as it is a parallelogram, a rectangle, and a rhombus. And my screen froze right at the end of that sentence, so let me unfreeze it. Okay, guys, sorry, the screen froze and the whole thing shut down. So there's the end there, where therefore ABCD is a square, as it is a parallelogram, a rectangle, and a rhombus. So today you're going to be doing work like this, today and tomorrow, the rest of this week, where you're going to have to be talking about this. It's important that you understand it's a parallelogram first, and then look at your conditions. Okay, so go ahead and get started on whatever other work you need to do.